Good morning, everyone.
Good morning.
Today, do we have... All right, sweet. Um, Jiayu from Intel has a proposal that he'd like some external feedback on. Um, Jiayu, I'll let you give the larger context around this.
Okay, sure. Thanks, Jeff. Let me share my screen.
Go for it.
Can you see my screen at all?
Yes, we can.
Yes, SPDM over TCP. So this is a binding spec being driven by the DMTF SPDM work group. As you guys know, DMTF is responsible for publishing the SPDM spec. And SPDM spec is application level spec, and there are many different transports that can work with SPDM. We have SPDM over PCIe, SPDM over MCTP. So in this case, we are trying to support SPDM over TCP, which is another popular transport that could benefit from the SPDM use cases. So the SPDM work group has been working on this for about a year. We published the work in progress draft earlier this year, in January this year. And the work in progress means it's not finalized yet. It's close to the final version, but we are seeking the public's review and comments on this work in progress. So any interested parties are encouraged to review this spec draft and submit any feedback. So I'm going to walk through some basics of this binding spec, SPDM over TCP, just give an introduction. Um, and certainly you guys should just look at the link and review the spec in more detail. But here's a high-level instruction. Um, so my colleague Algrado is also an author of the spec, so he's here to cover the second part of the use cases. So why do we do this? Why do we try to specify?
Look.
Sorry.
No, no. Mahir, if you could mute.
Um, yeah, so here's the advantages. So the SPDM over TCP will provide a end-to-end security communication between two endpoints, just like any other SPDM use cases. In this case, it could be a local or remote requester. So TCP will enable a remote requester as well, in addition to a local requester on the fabric. The SPDM enabled devices could be a platform root of trust or can be devices on the platform. So SPDM supports a wide range of use cases. For example, we support attestation or certificate provisioning. So those applications are very specific to SPDM. The general security protocols such as TLS or SSH do not cover those use cases. So in this case, it's very convenient to take advantage of what SPDM has to offer on the TCP transport. And in addition, SPDM is a live specification, meaning the DMTF is working on new releases of SPDM with the new use cases emerge. So we have a new release or new revision every about 2 years. We started from SPDM 1.0 and now it's at SPDM 1.3 after 5-6 years. So the binding spec, not only TCP, but any binding spec to SPDM could also leverage the new use cases introduced with the new SPDM revisions over time. Versus in other security protocols like TLS, is not very common to add new use cases. There's another advantage of SPDM over TCP. The other advantage is some device complexity could be eliminated if the device only needs to support one security protocol like SPDM. So you don't have to support two protocols. For example, the PA-IoT may need to use SPDM to communicate with the local AC IoT devices, but it may need to increment TLS to communicate with a remote server. In that case, it adds the complexity of the platform root of trust. But with the SPDM over TCP, the platform root of trust could just support the SPDM because it can also be used to communicate with a remote requester or server as well. And with that, we also eliminate the need for any proxy and protocol translation because we only have SPDM supported by the devices. So there's no need to do any proxy or policy translation. So we have two models in the SPDM over TCP we support. One is called the rich R model. In this case, the SPDM responder would initialize the TCP connection with the requester. In this case, the SPDM responder could be, for example, a local platform root of trust, and it would set up the TCP connection with a remote server. For example, it could be CA to provision the certificates, for example. So in this case, the remote requester is waiting for the connection from the local SPDM responder and provide services to the local responder. So after the TCP connection is established, the requester would issue the SPDM request. For example, you can get CSR, can provision cert, can get measurements. There are different use cases that can be performed here with the existing SPDM commands defining DSP 274. And at the end, the requester will close the connection after finishing all the services. The other model is the rich down model. In this case, the requester would initiate the TCP connection and send the SPDM request and serve the responder. At the end, it would close the TCP connection. So that's the two connection models. And in the draft, we also have a list of use cases defined in the binding spec. And we also define the flows of the spec and what SPDM messages. Those are the existing messages defining DSP 274 plus additional messages. We use the vendor-defined framework defined by this binding spec. Eduardo, can you walk through this?
Yeah, absolutely. Hopefully you can hear me.
Yes.
So yeah, so these are basically the first set of use cases that that we develop and are going to be leveraging in the near future. The first one has to do with basically the provisioning of device certificates for local device or secondary device credentials. In this case, the requester is basically a CA service, right? With TCP network access, and the responder will be the CI device in the case of what you mentioned, right? Perhaps a platform group of trust, for example, attempting to provision secondary credentials on a platform. And for that particular use case, we just simply leverage the SPDM messages, get CSR and set cert. So yeah, so using this flow, we can do remote certificate provisioning. The second use case has to do with performing verification or remote attestation effectively. The requester will be a verifier service, the responder platform group of trust. We would then retrieve the measurements, platform level measurements from the PA rod, check against some reference, a core RIM reference, and then send back a response. For these, is there a question?
Yeah, I have a question. Do you assume mutual authentication here? Suppose the attester is outside, right? And it tries to authenticate a responder right on the server. So do you assume that SPDM responder should be able to authenticate the requester?
Yes, that is correct. So we allow for both, right? So you can do in-session and out-of-session messages, right? So we support both. So in the case of in-session message, yeah, there will have to be mutual authentication.
So basically, in that case, if the responder is there in the server platform, so you have to, there's to some way to provision the certificates, right?
That is correct. Yeah.
Okay.
Yeah, the peer route will have to be provisioned with the the verifier trust anchor. Yeah. Yep. Perfect. And so in this case, since we're going to be leveraging the get measurement SPDM command, and we've defined a new command to actually obtain the verification result. So anywhere in the use case where no SPDM messages exist, where our binding specification defines vendor-defined messages to be able to complete the use case. So in this case, we have the SPDM get measurement, and then we define a vendor-defined verification result that allows the verifier, in this case the requester, to send back the attestation results to the peer route. And so other use cases, right, are retrieving a measurement event log, for example, from a device or the platform root trust. In this case, again, leveraging get measurements and get measurement detection logs commands. We also have a couple of additional use cases associated with delivering, let's say, a RIM to a P-Rod. So imagine a scenario when a P-Rod implements a local attestation flow and it needs a RIM. We can use SPDM over TCP to be able to deliver the RIM to the P-Rod using the vendor-defined set RIM command. And then lastly, in a similar scenario, a P-Rod implementing a local attestation would need, let's say, an operating policy delivered to it from a service. We can leverage this protocol to do that with the vendor-defined set policy command. So these are basically the 5 use cases that that we are going to be implementing. But we assume there'll be many more, and we're already working with DMTF on other scenarios. So this is the first set. Yep.
So if you guys have more scenarios or use cases, you can submit feedback. We can add to the binding spec. So I gave the link here. Please go and perform a review. It's not very long. It's a pretty short spec. You can submit the feedback through the DMTF portal or just send us email. Yeah, so hopefully you guys have a chance to read this and give us feedback. Thanks.
Thank you.
Just general question about the use cases. Does this imply that you need to have like a full TCP stack on everything running this protocol?
Yes. Both endpoints need to have TCP stack available. Yep.
So is this really that different than just using, I mean, SPDM was originally based on TLS. What's the point in not just using TLS at that point?
Hey, you wanna cover that? I think we covered in the advantages section.
Right. SPDM based on TLS. So to be very accurate, I think it's only the key exchange protocol. So the key exchange command and response, that specific message of SPDM is designed based on the TLS protocol. Not based on, but it's a similar protocol. So we don't have to do the invention of another key exchange protocol and the security analysis, right? So SPDM would take advantage of the TLS key exchange protocol, but the other SPDM use cases are not in TLS, including like we introduced like cert provisioning or measurements or attestation, and we're adding more use cases, right? Like authorization. There are other use cases, not in TLS.
So the TLS is basically a transport layer security, right? And this one is happening at the application layer, right? This protocol, right? So in many cases there will already be TLS, right? Suppose you're setting a HTTPS connection. So basically you will have one secure channel, this TLS transport channel, secure channel, and on the top of that you have this application layer stuff happening, right? So it is possible that the double encryption might be happening. And
No, we intend to replace TLS. So if you're using SPDM, you don't need the TLS.
yeah, I
It's
understand.
SPDM
Yeah, but TLS is happening at
Yeah.
transport layer, right? Suppose you are trying to connect to a verifier that is over the internet, right? So this is always a TLS, right? It is possible, right?
The intent is that you don't have to enable TLS, but could you send
Okay.
SPDM messages over TLS? Yes.
I guess the question is,
Okay.
why use SPDM secure transport instead of TLS? Right? I think I agree. It makes, like, intuitively, it makes more sense to just do SPDM as the application layer on top of TLS as opposed to, or sorry, do the existing protocol without the secure sessions and just do it on top of TLS at the point where you have a TCP stack. Like this feels weird, is I guess what I'm saying. To replace like a TCP secure session with this SPDM custom thing.
Well, I think it's 2 points, right? One has to do with if you want to enable, if you want to leverage SPDM capabilities, then you will still have to run SPDM over TLS, right? And so, it's redundant, right? So that was one thing. The other thing is we're trying to simplify the network stack, right? We're talking about potentially very constrained devices in the case of a AC rod or a P rod, right? So we're trying to, simplify the device network stack implementation by not requiring TLS, and so that's part of the point, right? The device already supports SPDM. Why not leverage that? But we absolutely are not saying we want to eliminate TLS. That's by no means what we're trying to do, right? What we're trying to say here is you have SPDM, you don't need TLS, and this is how you use SPDM over TCP directly. It gives you the same security properties that TLS and more, right? So that's our
but a couple of things about TLS, it has decades of security research in it, so it's tried and tested and pretty hardened, number one. And then number two, 443 is pretty widely accepted in most network firewall policies and so on. I think you're in conflating transport layer and application layer semantics. Your goal is very ambitious for this protocol. I personally don't see a use case for it anywhere. I think you might find some niche, use cases, but I'm kind of with Matt on that. Like, why not use what's tried, tested, and already pervasive in the industry and available in all tools and supported in all stacks that already have a network stack. Also, a lot of hardware acceleration out there already for TLS and DTLS. Adding something additional just to conflate, the application layer and the transport layer, it doesn't seem to make a whole lot of sense. And I think you may be underestimating, my advice is you may be underestimating how long it takes for an ecosystem to actually change. And, for an ecosystem to change, you generally need to have a really high value proposition. And this one's like, yeah, you know what? We can collapse app and transport into one, and it theoretically gives you great advantage for platform rooted trusts that have a network controller. And I don't know of any that have a network controller, and those that do are generally running a sophisticated operating system that already has TLS support. So you're solving a solved problem, but that's just my advice.
Does this work here presuppose that you have a root of trust with the network controller. I would have thought that all it needs to do is SPDM, and then the network bit of it, the binding, can happen outside the TCP.
Right, the network, yeah.
Mm-hmm.
The network is not in the TCP. So a few things here, right?
I heard the primary use case was for PRODs that had a network controller. No?
The TCP part can be excluded from the PROD, right? It can be a transport layer.
So then you can do TLS to like a BMC or something, and then just do regular SPDM over, PCIe or I2C or I3C to the PROD.
Right. That would require that you bring the BMC application processor into your trust boundary, right? Because it's terminating everything. Where it sounds like the goal of this work is to say, like, you can just do SPDM all the way down to the PA
end to end. Yeah.
Just anything in the middle.
I see, but does it? Oh, so it does like a binding? Is that what your proposal is? You can do a binding conversion from TCP on a VMC to I2C to a PROD or I3C or PCIe. Is that the goal?
That is not in the original design, but we are evaluating the possibility. Yep.
That's the original design, or that's
no, it's not.
The original?
It was not.
Oh, I see. Yeah.
But it is.
Yeah.
It is in the server space. We're looking to see how we can leverage some BMC internal BMC discovery mechanism is one of the things that we're trying to incorporate into the specification. So you can do things like you mentioned, right, where you terminate your TCP session on your BMC and then you utilize the other transport internally, right?
Yeah.
That's what we're looking at.
But I think what you're going to find is there's already existing methods to remove the BMC from being a man in the middle. Yeah. So I don't know whether you're trying to solve problems, but I wish you luck with this thing. For sure.
Yeah, I can speak to that final bullet. When we tried to remove the BMC from the trust boundary for attestation, we added a redfish translation layer, but that's protocol translation, so another spec in the middle. Brian, I'd be curious about some other mechanisms you're referring to about removing the BMC from the trust boundary. Anyways.
Yeah, we're aware, right? We understand the existence of other protocols. I think we're very early on putting together a proposal on how to leverage this in a BMC scenario. And we should we should ideally bring that here, right?
Hi, Maple.
We should bring that here, right? So when we have the proposal, we should bring it in. We'll bring it in, have that conversation, because I think that's the conversation. I think it'll be of more interest to OCP.
Right. Ben Stoltz, I think your mic is unmuted. Thanks. Cool. Is there anything else you wanted to discuss on this? All right. Cool. Jayu or Eduardo, thank you for bringing this.
Yeah, thank you.
Appreciate the feedback, folks. Thanks so much.
With the balance of our time, I didn't send word out earlier for this, so I don't know if we have all the right people in the room, but we do have, after a lengthy internal legal review, we have all our ducks in a row, Google's ducks in a row anyways, for the OCP attestation 1.1 specification, which I know has been kind of in the pipeline for a while. So I'm not going to complain about anyone else's companies having slow legal flows anymore, because that would be hypocritical. But so we have that. I think it would be good to have a discussion about that document, all the new stuff coming on, primarily about SPDM. Trying to put together a list of things which, like a profile of commands which need to be supported in data center environments. Let me see if I can. So yeah, I think it would be good, I think, for the primary authors of that specification to drive this discussion. So I'm not going to try and do that, but I think I will send the document out so people can look at it asynchronously, and then we can schedule a talk about it when we next meet. So, oh, and there is one piece of discussion which we'll have to have as part of that. I don't have slides ready yet, but it comes down to what to do about SPDM's get CSR command, and how to deal with some language from DMTF. Basically, the TLDR is one reading of the of get CSR from SPDM says you must give a CSR over the lowest key in your dice hierarchy, being like the device ID key, which is a problem for certain implementations where that lowest layer of the dice key cannot be used once you've booted to generate anything else, because it's been locked away, and all it can do is make an alias certificate for the next layer. This is in fact how Calyptra works. However, looks like there is some room for interpretation where a device could, instead of yielding a CSR for the very, very lowest layer dice key, could go a bit higher, which is in fact what is actually wanted in many cases. You want a key that's a bit higher in the dice stack so that if you rotate the FMC, you invalidate the certificate corresponding to that CSR. So that's just something we want to talk about when we talk about whether this, how this spec addresses the get CSR command. Because we're trying to enumerate all the commands which must be supported. So with that, I will send the document out. People can review it. And yeah, I think we can, let's talk about when we're going to meet next, because OCP is next week. So that's cool. Brian, I think you'd mentioned, I use Brian's, yes, I think you mentioned possibly doing a topic preview of the talks we're going to see at OCP next week.
Yeah, but I don't think we landed on that for this week. So I think we'll have to do maybe a recap when we get back.
Okay. Yeah, that's cool. And the agenda's out there, so y'all can go check out the sequence of talks which are going to be coming up. So looking forward to it. So it's going to be some good stuff. So next week we're not meeting. The week after, I will not be available. I think people might still be out from the conference. So you could plan on reconvening on May 7th and go from there.
Yeah, that sounds great.
Okay. Thank you all for the time, and give you 28 minutes back.
All right. Thanks a lot, Jeff. Thanks, Xiaoyu, for coming in and presenting today.
Thank you.
All right. Bye.